Have you ever just wondered what would happen if you stepped out onto another planet? No spacesuit, no protection, just you against the elements? Well, today, we're going to take a tour, a pretty grim one, I'll admit, of 20 other worlds to find out exactly how long you'd actually last.
So, what really goes down? I'm not talking about some sci-fi movie scene with dramatic gasping. I mean the real, hard physics of what the cosmos would do to a human body. That's the big question we're tackling today.
You should probably think of this as the ultimate one-way trip, a grand tour of all the ways the universe can get you. So, buckle up. Not that it's going to help.
Okay, let's kick things off close to home with our deadly inner neighbors. And you're about to find out that just because they're neighbors doesn't mean they're friendly. First stop is Venus. See, its atmosphere is this crushing, thick blanket of carbon dioxide, which has created a runaway greenhouse effect. That means in less than a single second, two things happen at once. You're crushed by atmospheric pressure that's 90 times what we feel on Earth, and you're incinerated by temperatures hitting 878 degrees Fahrenheit. Your airways would literally flash into ash. All right, next is Mars. Its atmosphere is super thin, like 100 times thinner than Earth's. And this brings us to a super important rule we're going to see a lot, so let's just call it the vacuum rule. In a near vacuum, your first instinct is to hold your breath, right? Worst possible idea. The air in your lungs would expand and pop, they'd rupture. So you exhale, but then the vacuum just rips the oxygen right out of your blood. The moisture on your tongue, in your eyes, it starts to boil. You'd pass out in about 15 seconds and be gone for good in about 2 minutes. That's actually your best case scenario on Mars.
Moving on to Mercury, a planet of crazy extremes where you actually get to choose how you go. On the side facing the sun, you'll burn up at over 800 degrees. On the night side, you'll freeze solid at nearly 300 below zero. And since Mercury basically has no atmosphere, our good old vacuum rule is in full effect. So pick your poison, boiling or freezing. Either way, you've got about 2 minutes.
Okay, leaving the rocky planets behind, let's head out to the big guys, the gas giants. And, well, let's just say the survival timeline gets a whole lot shorter out here.
So on Jupiter, there's no ground to stand on. You just fall, and you keep falling through these incredibly beautiful swirling clouds of toxic ammonia. But you don't get to enjoy the view for long. The atmospheric pressure builds up so fast, so intensely, that within a second, you just implode.
Saturn. I mean, come on, it's got the most incredible view in the whole solar system, right? The rings, but you're not going to see them. You're immediately getting hit by winds blowing at 1,100 miles an hour as the massive, massive pressure just collapses your body, all in under a second. Now here's a weird fact for you. Uranus stinks. Thanks to a bunch of hydrogen sulfide, it smells like rotten eggs. It's a very strange last thing to experience right before the extreme pressure turns you into a pancake in, you guessed it, less than a second. And last up, Neptune. This might just be the most violent end of all. Here, you get torn apart by supersonic storms, while at the exact same time, you're flash frozen by air that's over 300 degrees below zero. It's a 2-for-1 deal. So, what's the big takeaway for the gas giants? It's simple. On all 4 of them, your survival time is less than 1 second. End of story. Okay, let's leave our solar system. We are now heading into the wild world of exoplanets, where the universe gets even more, creative with its methods.
Let's do a quick-fire round for our first few exoplanets. On Proxima Centauri b, you get blasted by a massive radiation burst from its star. On Barnard Star B, it is so cold your windpipe freezes solid instantly. On Ross 128b, it's actually kind of peaceful. You just suffocate on the alien air. And on Wolf 1061c, toxic gas makes your lungs seize up. But notice the pattern? For all the different ways to go, you're still looking at about a 2-minute survival time.
But not every exoplanet is so generous. Take Gliese 876d. It's a volcanic nightmare. You don't land here. You impact a literal ocean of bubbling lava. The first and only breath you take is superheated air that vaporizes your lungs from the inside. We're talking milliseconds of survival, if that.
For our final leg, we're taking a trip 39 light-years away to the TRAPPIST-1 system. It's this incredible collection of worlds, all orbiting one star, and each one has its own special welcome party for us.
Let's start with 2 neighbors. On TRAPPIST-1b, you're so close to the star that the intense heat and radiation would just melt your windpipe shut, instantly.
On its neighbor, TRAPPIST-1c, it's like Venus all over again. Crushing pressure and toxic gases burning your lungs. For both of them, you're gone in under a second.
But then we get to TRAPPIST-1d, and for just a moment, you think you've hit the jackpot. It's a world covered in a shallow, lukewarm ocean. It honestly sounds like a vacation spot.
But that vacation is over before it starts. The water has zero oxygen. The second you go under, you drown. You're in a planet-sized alien bathtub with no way to breathe. That gives you another 2-minute window.
And that brings us to our final world, TRAPPIST-1e. And it is beautiful. You're standing on this frosty landscape, looking up at a sky filled with other planets. But the air itself attacks you. The alien gases trigger this violent, unstoppable coughing fit that forces every last molecule of oxygen from your lungs. You'd suffocate long before you'd freeze. Your time? About 2 minutes.
So after that cheerful little trip, we're back home. And the difference couldn't be more clear.
This chart kind of says it all, doesn't it? Out of the 20 worlds we just visited, 9 of them kill you in less than a second. 10 of them give you about 2 minutes of pure agony. And then there's Earth. The data makes it pretty obvious. The default setting for a planet is incredibly, overwhelmingly hostile to us.
And that leaves us with one last thing to think about. After touring 20 different places where human life is utterly impossible, you have to ask, what is it about this one tiny blue dot in the universe that makes not just survival, but all of this life possible in the first place?